right, Fun Nation, welcome back to Behind the Bumpers. My name is E. Lockman, and I am here at Kettering District Event number 1 with Team 910, the Foley Freeze. We're here today with Kate, Libby, and Caitlin to talk about their innovative end effector, their literally infinite autonomous paths and control board, and the really awesome aesthetics behind this robot. So look for all this and more on Behind the Bumpers. All right, now we've got Kate here to talk about their innovative end effector and carriaging system. Kate, take it away.
All right, so our arm works through our carriage here. We have our 2 motors hooked on the back here, and this moves up and down with our elevator. This works for both our coral and our algae intake through the same running wheels. We have a dead axle here so that this this pulley on the end can move to adjust the angle of our virtual 4-bar, and it also is able to move here without affecting that. So we start and we gather our coral through the funnel here, and it will pull around and adjust the angle, keeping the angle the same to the ground the whole way through because of the virtual 4-bar. And that way we are able to place the coral at the angle we wish with only one program. So this also works for the algae. The bucket will flip down, and the same running wheels will take the algae in through here, and it will place it out the same way. So it fits like that.
Wow.
Yes.
This looks really awesome. Why don't you demonstrate the robot and let's get a breakdown of it as it's going.
So our coral passes through the funnel to there and all the way up.
Outstanding. All right, folks, now we've got Caitlin to talk about the general aesthetic of the robot and the very tall bumpers.
Yes. With the new bumpers this year, we had a lot more leeway in designing and making them look very nice. And same with our media panels. They are not only just for decoration and to shout out our sponsors, but for strategy. So we purposely did it all around the bottom, so coral cannot get stuck in the robot. And we also have over 40 CNC parts and 3D printed parts on this robot.
All right, now we've got Libby to talk about their innovative control board and literally infinite autonomous paths.
You say literally, but it's actually only 24,330,240 in 2, which includes do nothing and just drive forward. And that's because we have a selectable autonomous, which means that before every match we just select our starting position, and we use where we want to score based on the letters of the reef and then the level we want to score on, and we could just do that repeatedly. Over here we have our control board, which contains a diagram of the reef, which is lettered and labeled, even though we have them memorized. And all I have to do as operator is switch the level switch, always forward, and then click on the letter that we want to score. Then all our driver has to do is use our drone controller that we use as our robot controller, and to use the left switch to gather and right switch to score. It's fully autonomous, so she can pull the score switch from the gather station and it'll drive automatically to the reef. We end up with so many controls that we actually end up running out of buttons, believe it or not, which is why we use the shift button to double our amount of buttons that we have on the control board. What the shift button does is it changes the function of every single button and switch on here so that we can have twice as many options. These are jogs. We have 5 subsystems that we need to jog. We use that so that in a match, if we get offset by any amount or skip teeth, we're able to correct ourselves and keep playing.
Awesome. Now talk to me about the design choices here with the control board. So why exactly did you choose the switches and the buttons that you did?
So what we do is we have a drive meeting every year, or a control meeting every year to decide how we want to do it. This year's was about 2.5 hours. And what we do is we work backwards. We want to say, how do we want to play the game? What components do we want to have? Because we already have our robot build at this point, so we're saying, how do we want to use this? And then we decide what buttons best present that. So usually it comes down to preference too of whoever's operating or driving. What's going to be easier to them and what makes sense in their head.
All right, folks, this has been another edition of Behind the Bumpers here at Kettering University District Event number 1. I want to give a huge thank you to Team 910 Foley Freeze and Kate, Caitlin, and Libby for their awesome work here today. And we will see you guys in the next episode of Behind the Bumpers.